On June 5th, 2018, we heard about ZipSlip. We just disclosed a widespread critical vulnerability called ZipSlip. It may affect you. ZipSlip is a widespread, arbitrary file overwrite critical vulnerability which typically results in remote command execution. It was discovered and responsibly disclosed by the SNCC security team. Coincidentally, a couple of weeks before that, we heard about ZipperDown. While auditing iOS apps from various customers, Pangu Lab noticed a common programming error which leads to severe consequences, such as data overwritten and even code execution in the context of the affected apps, and then listing almost 16,000 apps that could be vulnerable. What is going on with zip files? Why can it lead to remote command execution? And why is it affecting everything? In case of SNCC security, several CVEs were assigned. It's like a massacre. So first of all, what do those two different disclosures have in common, ZipSlip and ZipperDown? So when ZipperDown was made public, they wrote that to avoid leaking the details of the programming error, we named it ZipperDown. So they didn't want to disclose what exactly was the issue. But if you have experience in IT security or maybe played CTFs, then it was pretty obvious what was going on. My guess at the time was zip archive unpacking with path-traversal from resources downloaded via an insecure connection. It allows to overwrite files inside the app's sandbox folder and in some cases even RCE. The proof of concept video shows code exec in JavaScript, so they probably overwrote some HTML or JavaScript files. And yes, that is basically what it is about. It's about having relative path, or more specifically with a path-traversal ... as files in the archive. This allows you to go up in the folder hierarchy and write to files and folders outside of the intended unpacked destination directory. And of course, when you have a software that takes a zip file and unpacks it and allows path traversal, maybe some important files can be overwritten, and that could open doors, like overwriting a script that would be executed later or stuff like that. And the reason why I was able to guess this is because I play CTFs, and screwing around with zip files or other archives is a very typical challenge, a typical beginner challenge. But actually, this issue with zip files is ancient. Hackers have exploited this before I even existed in the world. Check out this Frag article from 1991 that's over 27 years old. Let's check it out, it's hacker history. The Complete Guide to Hacking WWIV by Inhuman, September 1991. WWIV is one of the most popular BBS programs in the country, that's like a forum, with thousands of boards in WWIV.net and hundreds in the spin-off WWIV link. There's a lot of support and community. The nice thing about WWIV is that it's very easy to set up. This makes it popular among the younger crowd of sysops who can't comprehend the complexities of fossil drivers and batch files. In this file, I will discuss 4 methods of hacking WWIV to achieve sysop access and steal the user and configuration files. I don't want to read the whole thing, but let's jump ahead to this section. This technique also plays on the openness of WWIV's archive system. This is another method of getting a file into the root BBS directory or anywhere on the hard drive for that matter. And then down here it explains, load stuff.zip into a hex editor like Norton Utilities and search for AA, blah blah. You could even work backwards by forgetting the WWIV subdirectory and just changing the AA to ... This would be foolproof. You could work from there doing ... DOS pkzip.com or whatever. Then upload stuff.zip or whatever you want to call it to the BBS and type E to extract it to a temporary directory. So this was done in different times when more servers were running DOS, but it's the same issue, exploiting a path traversal when unpacking zip files. So maybe now you can understand why it is a little bit misleading or disappointing how SNCC marketing team advertised this with "we disclosed a widespread critical vulnerability called ZipSlip," and they write it was discovered and responsibly disclosed by the SNCC security team. It's just not accurate. Zip files and many other archive file formats just can contain relative path and thus path traversals. It's not forbidden in the specification, and like we just learned, it's known since forever. I mean, even the Python doc for zip files has a huge red warning saying, "Warning, never extract archives from untrusted sources without prior inspection. It is possible that files are created outside of the path, for example, members that have absolute file names starting with a slash or file names with 2 dots, ... So I hope I made it clear that this is nothing new or surprising. In their white paper, they also claim that the contents of zip files have to be handcrafted. Archive creation tools don't typically allow users to add files with these paths, despite the zip specification allowing it. I don't know, but the zip utility on most systems will happily include files with a relative path and path traversals. See here, simply creating a zip file with a relative path, and there it is, no problem at all. And I understand that this fact about zip files might come to a surprise to many developers, but the security team of Snyk should know better. They themselves write, despite the zip specification allowing it. They know this is known. So phrasing it in this way that they discovered this issue and hype it up this much and give it a name, especially because Pangu released basically the same thing, just more specialized for iOS apps a little bit before that with their own name, I don't know what to say. I like to believe that the researchers were maybe a bit overexcited or didn't have much say in it, and the less technical marketing department took it a few steps too far. But despite the little bit cringy overhype and kinda misleading advertisement, this is probably positive work. So they reported this to many libraries that happily follow the zip specification. And changing this in the libraries means violating the specification, right? Violating the spec means you think you know that a zip unpack behaves as you expect, but then it doesn't. And there are a lot of specification purists out there that will tell you that you should never diverge from the specification, because then what resources can you trust? But zip is very old and has been created in a time where there was probably not much deep understanding of security issues that could come from it. I mean, the computer systems were so different back then anyway. And today we can see so many serious vulnerabilities that happen because of that. And while refusing to unpack path traversal files might violate the spec and break some implementations that relied on that, probably the majority of the world will be fine. And so not only did they report this to the library so they can change that behavior, they actually did that with pull requests. They didn't just complain, they fixed it themselves. And I think that deserves credit. And so overall this effort will probably have some positive effect for security in the future if these libraries stay relevant. Though there's still the issue that maybe we should update the zip standard itself so that future reference implementations won't allow it by default. Maybe we could introduce a flag to optionally turn it on. And so it's kind of a shame that they didn't market it this way. Instead of marketing it like any other hyped vulnerability and claiming they discovered this, they should have written about the decades of issues with zip and their effort to get libraries fixed, which will then lead to software built on these libraries to be safe. This could have impact. That would have been genuine and honorable. But unfortunately, the reality is, advertising it in this terrible way will probably help their business more. Who cares what some researchers think if they can use it to fish for the big contracts by being mentioned with flashy headlines in the news, and then they get what they wanted. And that's a little bit sad. But let's not stop with the video here, because zip files and other archive files are effed up. If you are a developer and this was new to you, then please research more about zip files. I can really recommend the work from Ange Albertini, who has done several presentations on file formats and zip files, and has done a lot of experimentation with them. For example, crafting a PDF with an issue of POC or GTFO, which is at the same time a bootable image and also a zip file that can be unpacked. Funky file formats. Or Gynvael, who also has a great YouTube channel and has recently done this great talk, 10,000 Security Pitfalls, the zip file format. I guess that title says it all. So you should definitely look up his slide and talk. I will list some links below in the description. And by the way, I was talking with Gynvael about the zip slip issue, and he had an excellent idea. You know, zip files or other archive files sometimes also support symlinks. Not every library implements symlinks, but if a library supports symlinks, you could maybe bypass those path traversal fixes. Again, this is something you could learn from playing CTFs. Here's just a short excerpt from a challenge extractor from 34C3 CTF. This write-up is by the challenge author, Eboda, and he writes, "If you have been playing CTF for a while, you know that when you can extract or compress zip archives, you probably have to do something with symlinks." So yeah, that's also pretty common knowledge. And I wanted to try Gynvael's idea. I went down the list of libraries that were fixed by the SNCC security team. Their patches are supposed to fix the path traversal. Unfortunately, as expected, a lot of libraries don't implement symlinks, especially for zip files, even though the standard theoretically supports it. But this one Go library supports symlinks for tar archives. Here's the original issue from the SNCC team to fix the path traversal, and as an example, they use tar. So let's see if we can bypass the fix. I create a zip test directory in TMP and create also a file inside TMP. Then I create a symlink called root that points to the root of the file system, /. Now we create a test.tar file and include the symlink root and reference the file we created in TMP via following the root symlink. And when we list the archives, we see those files now. Here's a simple Go program that uses the library that I just mentioned to unpack the test.tar into the folder testout. Let's remove the OO file in TMP and then go run test.tar. This should have now unpacked the files. And here's the testout folder, and it does contain our symlink. And when we now check /tmp/oo, then yeah, our file is there. We bypassed the fix. You see, fixing common issues with archives is not that simple. Zip files and archives are dangerous, and developers should be educated about it, and maybe ZipSlip helped raise awareness, I hope. Otherwise, you can share this video with your developer friends to give them a little look into the world of IT security and why they should care about learning more about zip files. And I leave you with the beautiful summary by Gynvael, 10,000 security pitfalls, the zip file format.